In this video, I'm going to solve a couple of applications involving trigonometric equations. A coil of wire rotating in a magnetic field induces a voltage modeled by the equation E equals 20 times sine of pi over 4t minus pi over 2, where t is time in seconds. We want to find the smallest positive time to produce each voltage. So basically, we just have two different problems to do here. Part A, E equals 0. Part B, E equals 10 square root of 3. We'll just plug that value into our equation for E and solve for T. So our first equation to solve will be 0 equals 20 sine of, right, this is pi t over 4, but really that's like pi over 4t, same thing, minus pi over 2. And we're solving for t. This is a trig equation containing a single trig function, so we want to isolate that one and only trig function. We'll start by dividing both sides by 20. We get 0 equals sine of pi over 4t minus pi over 2. Now that we've isolated the one and only trig function, we want to use our inverse trig function to help us solve. This becomes sine inverse of 0 equals pi over 4t minus pi over 2. Now we want to find where sine is equal to 0, and our directions said we want the smallest positive time. So let's find the smallest positive place that sine is 0. So sine is 0 when we have a height of 0, which happens here and here. Well, I want the smallest one. Right, and this is 0 and this is pi. So I'm going to take the 0. Sine inverse is 0 will be 0 equals pi over 4t minus pi over 2. And now we're just going to solve for t. We'll add pi over 2 to both sides. And then we'll divide both sides by pi over 4. Another way of thinking that is multiplying by the reciprocal of 4 over pi. That's how I'd opt to think about it. All right, that's going to disappear and leave us with just t. And here on the left, this will be easy for us to simplify. 4 over 2, we get 2. And our unit is seconds. So let's try part B. It's going to be like pretty much exactly the same process. It's just we'll be finding sine inverse of a different number. So plugging 10 square root of 3 in for E. You know, this might even be a great place for you to pause the video and then do this one on your own and then check it out, since it's just like part A. We're going to start by isolating our one and only trig function by dividing both sides by 20. It's going to give us a square root of 3 over 2. Equals sine of pi over 4t minus pi over 2. Now that our one and only trig function is isolated, we'll rewrite it using our inverse trig function. Sine inverse of square root of 3 over 2 equals pi over 4t minus pi over 2. We need to figure out the smallest positive value where sine inverse is square root of 3 over 2. Oh, that's positive. So quadrant 1 is going to be our smallest positive sign value. Square root of 3 over 2 is the long side of our 30, 60, 90 triangle. So the x is going to be our short side. The y is going to be our long side. We're looking at a 60-degree reference angle here. But it's important that we are in radian. Right? So this is pi over 3. So sine inverse is square root of 3 over 2 will be pi over 3 equal to pi over 4t minus pi over 2. And then we'll solve for t. First by adding pi over 2 to both sides. You can use your calculator to help you with this, right? That's why I love my TI 30 so much, because it's great with fractions, right? Pi over 3 is 1/3 pi, and pi over 2 is 1/2 pi. So you could just put in your calculator 1/3 plus 1/2, get your answer, and then put the pi on it. Or you could get yourself a common denominator of 6 and do it that way as well. Either way, when we add pi over 3 plus pi over 2, we're going to get 5 pi over 6. That's still equal to pi over 4t. And then we'll divide both sides by that pi over 4, which is the same as multiplying by the reciprocal. We're left with just t on the right, and on the left, our pi's cancel out. I can simplify the 4 and the 6 by 2. And we get 10/3, and again, our unit is seconds. Let's try another example. When throwing an object, the distance achieved depends on its initial velocity, which we call v sub 0, and the angle above the horizontal at which the object is thrown. We'll call that angle theta. The distance d in feet that describes the range covered is given by this formula here. This is not one that you need to know. The distance is equal to the initial velocity squared divided by 16 times sine of theta times cosine of theta. And our initial velocity is measured in feet per second. You and your friend are throwing a baseball back and forth. If you throw the ball with an initial velocity of 90 feet per second, at what angle of elevation to the nearest degree should you direct your throw so it can easily caught by your friend located 170 feet away? They've given us our initial velocity. They've given us our distance d. I'm going to plug those two things into our formula. So 170 is equal to 90 squared over 16 times sine of theta times cosine of theta. And we need to solve for theta. Well, I'm going to start by squaring that 90. Becomes 8,100. And then I think I'm going to get rid of that fraction there on the right side. Let's divide both sides by 8,100 over 16, which is the same as multiplying by its reciprocal. We can do some simplifying here. I can lose a 0 for sure. I can also simplify the 16 and the 810 that it's left. I can simplify both of those by 2. So this becomes an 8. This becomes 405. Multiplying straight across, we'll get 136 over 405 equal to sine of theta cosine of theta. I just did like some cleanup, so I feel like I see what I have and think. Well, right away when I look at this equation, I don't like the fact that I have 2 different trig functions. Right? We like to have just one. And there's not really an easy way to get rid of a sine or a cosine. But I do see sine times cosine, and I feel like that's familiar. If we look at our trig formula sheet, we'll see that sine of 2 theta is equal to 2 sine of theta cosine of theta. And although we don't have 2 sine of theta cosine theta, we could make it that. If I multiplied both sides by 2, we'd have 272 over 405 equals 2 sine of theta cosine of theta. And now I can substitute sine of 2 theta in for that 2 sine cosine. I'm down to a single trig function, which makes me happy. So now I can apply my sine inverse. 2 theta is going to be equal to sine inverse of 272 over 405. Note that in our application, our angle theta is measured in degrees. So we need to make sure that our calculator is switched back into degree mode. And we're going to do sine inverse of 272 over 405. That's going to give us 42.191. And then lastly, to solve for theta, we're going to divide both sides by 2. We end up with, and remember we're rounding to the nearest degree, theta equal to 21 degrees.